Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 2 for Math 8, Module 1, Lesson 2, Multiplication of Numbers in Exponential Form. Okay, so in general, if x is any number and m and n are positive integers, then x to the m times x to the n equals x to the m plus n. Okay? All right. Now, x is called a base, so it's the base to the power. Those are what we call them. Or we could say this is a base, and it's an exponent. Okay, so when we're multiplying bases with this rule, the bases have to be equal. I cannot say 5 squared times 5 to the 5th, or 4 to the 5th, we'll say. 5 squared times 4 to the 5th. I can't do that with this rule. The bases have to be the same. So the rule says that x to the m means it's x multiplied m times, and x to the n means x multiplied n times. So if we multiply x, say, 5 times, and then multiply x 3 more times, that's a total of 5 plus 3, or multiplying x times itself 8 times. Okay? So in this exercise, first thing we should always do is make sure the bases are equal. So the base here is 14, the base here is 14. So therefore, since we have an x times an x to a power, we get an x to a sum of powers. So I know that my base is going to remain 14. And then I take my two powers and I multiply. Since we're multiplying, I add my powers. So I'm going to take 23 plus 8. Now I want you to show your work on these until you get the feel for this, and that will just help you solidify the rule. So 14 to the 23 plus 8 is 14 to the 31st power. Okay? Let me change the color of that since we're doing exponents in green. So this is 31. So it's 14 to the 31. So in this exercise, it's not asking you to take 14 and multiply it by itself 31 times and give me this big, humongous number that's bigger than the Powerball lottery from last week. All they're asking you for is what is it going to become in terms of a base to a certain power. So now that I've explained exercise 1, pause the video, see if you can do the rest of these, and then come back and see how you did. Okay, so here we go. Here's exercise 2. Negative 72 in parentheses times negative 72 in parentheses will give me a negative 72 in parentheses, and then it's to the power of 10 plus the power of 13. So my answer is going to be negative 72 to the power of 23. Okay. Number 3, my base is 5. My base is 5. I will still have a base of 5. My exponent is 94. My other exponent is 78. So if we're multiplying bases, we add exponents. So my answer is going to become 5 to the power of 94 plus 78, which is 172. Exercise 4, the base is negative 3, the base is negative 3. It's in parentheses, so it's got to stay in parentheses. I explained that in lesson 1. And the exponent is 9, and the exponent is 5. And when we're multiplying, we add exponents, 9 plus 5. So my answer is going to come out simplified. It's not the answer, it's a simplified form. Negative 3 to the power of 14. Okay, number 5. Base A will yield base A. 23, 8, 23 times 8 equals, base doesn't change, A to the 23 plus 8, my apologies there, it's plus. 23 plus 8 is 30. Okay. Exercise 6, the base is F. The base is F. the base remains f. The exponent's 10, the exponent's 13, 10 plus 13, and then simplify. That will give me the base f to the power of 10 plus 13, which is 23. Okay, number 7, base b will give me base b. 94, 78, going to be 94 plus 78. And when I simplify that, I'm still going to have a base of b, and I'm going to have an exponent of 74 plus 8, which is 178. Okay. Exercise 8. Let x be a positive integer. If negative 3 to the 9th times negative 3 to some number equals negative 3 to the 14th, what is x? Okay, so we know we're going to have a base of negative 3. Because we have a negative 3, we have a negative 3, we have a negative 3. In this case, we have some value 9 and some value x having to equal 14. So if I do this in the same format, then I'd have negative 3 to the power of 9 plus x. And that has to equal what I have on the other side, which is negative 3 to the power of 14. Okay, so we're leading into almost like an algebra 2 rule here, where whenever we have bases that are the same and we have an algebraic equation in our powers, we can eliminate or ignore our bases to solve for our exponent variable. So if we have 9 plus some number has to equal 14, we can simply ignore the negative 3's and just focus on 9 plus x equals 14. Subtract 9 from both sides, solving this algebraically, and 9 minus 9 is 0. X minus nothing is x equals 14 minus 9, which is 5. So 9 plus 5 is obviously 14. I just wanted to show that algebraically. Okay? Okay, exercise 9 and 10 are showing a multiple of bases with different exponents, and it says what would happen if there are more terms with the same base? Write an equivalent expression for each problem. So the same rule applies here, so pause the video, see if you can do these two, and then come back and I will go over them with you. Okay, so in this one I have a 9, I have a 9, I have a 9, therefore I'm going to get a 9 for a base in my solution, in my simplified solution. So I have a 4, I have a 6, I have a 13, and we add exponents when we are multiplying. So that is going to give us a base of 9 to the power of 4 plus 6, which is 10, plus 13, which is 23. So the answer is 9 to the 23rd power. Okay, exercise 10, base 2, base 2, base 2, base 2. My simplified solution will have the same base of 2. I'm adding 3, 5, 7, and 9. So it's going to be 3 plus 5 plus 7 plus 9 for my exponent. And when I simplify that, the base does not change. I have 2. And 3 plus 5 is 8, plus 7 is 15, plus 9 is 24. 2 to the 24. Okay. Can the following expressions be written in simpler form? If so, write an equivalent expression. If not, explain why not. Okay, so these are getting a little bit more complex. You have to think about it. And if you have bases that are not the same, can you represent that base a different way? So try this on your own. I will say it is a little bit tricky at first, but just give it a shot, pause the video, come back and see how you did. Okay, so in starting this, I have to look at bases. So let me stick with the same colors here. All right, I have a base of 6. I have a base of 6. But in this situation, I have a base of 4 and I have another base of 4. So if I did a factor tree off to the side for 6, it's 2 times 3. And if I did a factor tree for 4, it's 2 and 2. Okay, so if 6 is 2 times 3, it cannot be represented in terms of just 2. and that's all 4 is represented. So I can't make 6 a multiplication problem with 2 to the power of something or 3 to the power of something. So I can't really simplify that. So all I'm able to do here is come out with a simplified 2-piece multiplication problem. It can't be simplified any further without getting the actual answer, which is not what is being asked for. It says, can it be written in a simpler form? So 6 is going to be to the power of 5, and this 6 is to the power of 14, so it's 5 plus 14. And then I'm going to multiply that by, let me change to purple for this, or actually I used blue already, the base 4. So let me use black for the multiplying. So I have 6 to the power of 5 plus 14. These are these two. And now I have the 4 to the 9 and the 4 to the 3. So I can multiply that by 4 to the power of 9 plus 3. Okay. Since these bases are not the same, I cannot multiply them together and say it's 24 to the sum of all of these. That would not be correct. Okay. But what I can do is simplify this and say this is 6 to the power of 19. And I'm going to multiply by 4 to the power of 12. Okay, so I did it in a simpler form without actually finding the actual number, but that is as simple as it can get. Okay. All right, exercise 14 is a little different. 2 is a prime number, so I can't do a factor tree for 2, but 8 is 2 times 4 and 2 times 2. So 8 equals, let me rewrite that, a little messy. 8 equals 2 times 2 times 2, or 2 to the 3rd power, right? 2 times 2 times 2 is 2 cubed, and 2 cubed is 8. So I can change this first, so let's just not change any colors yet. I have 2 to the 4th times 8 is 2 cubed, so I'm going to put that in parentheses, so that's 2 to the 3rd power squared equals 2 to the 4th times 2 to the 6th and what does that mean? So I just wanted to show you where this 2 to the 6th came from. So 8 is 2 cubed, and 2 cubed twice would be 2 times 2 times 2, 2 times 2 times 2 times 2. Well, there are 6 2's there, and that's where this 2 to the 6 came from. Okay? So now with that said, we now have a base of 2 to the power of 4 plus 6, which is 10. So this is our simplified solution. Even though these bases weren't the same, we can make them the same because we have a multiple of the other base that creates this composite 8. Okay. Exercise 12. Let's erase some of this other stuff that's hanging over, distracting. And go back to here. Alright, so I have a base of -4. I have a base of -4. 17 is prime. I cannot combine those two, so I'm just going to focus on the -4 first. And I have a power of 2 and a power of 5, and I add that, 2 plus 5. Okay, and then I'm still going to be multiplying by the other base, which is 17. So it's going to be 17 to the power of 5. I'm sorry, yes, 5. Plus 7. Okay, I made a mistake here. I just cut that. So let's erase this. So I need to add 2 and 7, not 17. So that's 2 plus 7, or 5, not 5. All right, so my new base for, so everybody see that, 2, -4 to the 2, and -4 to the 3. Okay, still made a mistake there. All right. Gotta be more careful here. 3, 2 and 3, add the 2. Alright, and then we're going to multiply by the other base, which is 17. That's going to stay the same. That's going to be taken to the power of 5 plus 7. Okay, so now I'm going to simplify that down below. Let's keep it in the colors, -4 to the power of 5 times 17 to the power of 12. And that is my simplified version. Okay. So here they did the first step for us, and that's where this 9 came from. 9 is equivalent to 3 squared. So 3 to the 7th times 9 equals 3 to the 7th times 3 squared. Because 9 and 3 squared are equivalent. So now I get a base of 3. And 7 plus 2. Actually, I should stick to my color coding. Base 3, base 3, base 3, 3. To the power of 7 to the power of 2, 7 plus 2 equals base 3 to the power of 9. Okay. So here I have a prime number 7. And 7 won't go into 15, so I can't make 15. 15 is 3 times 5. I cannot do anything with these bases like we did with the 9 and making it 3 squared, so our bases are equal. There is no 7 to an integer power that will give me 15, so I can't combine these two. So I have to focus first on my base 15, and my base 15 will give me a base 15. My base 2 and my base 1, there's nothing there, it's a 1, is 2 plus 1. I'm going to multiply that by 7, my base 7 to the power of 2 to the power of 4 is 2 plus 4. Okay, that is going to equal 15 to the power of 3 times 7 power 6. Okay. Base 5, base 2, they are not the same. They're both prime. I can't make 2 to any power become 5. So I can't combine these bases. There is no way to simplify this. So we are just going to leave that. So it says, if not, explain why or why not. Okay. So our bases aren't the same. I'm not going to write this. I'm just going to say it. Bases are not the same. And we can't get the base to be equivalent to one that has the same base if they are not the same. Okay. 2 squared is 4, 2 cubed is 8, 5 is between 4 and 8. No way to get 5 from 2s. So, can't do it. Number 17. Let x be a number. Rewrite the expression in a simpler form. Okay, so we have 2 times x cubed times 17 times x to the 6th. Okay, in this situation, this 2 is called a coefficient, the x is a variable, and 3 is my exponent. My base here is the x. So think of this as 2 times x cubed, and then multiplying that whole thing by 17 times x to the 7th, okay? And then if we rearrange these parentheses, I can pull the 2 and the 17 out. 2 times 17. And regroup these, and then multiply that by x cubed times x to the 7th. So all I did was put like terms together. 2 times 17 are my 2 coefficients, x and x are my bases, and then I can simplify that. 17 times 2 is 34, and then x to the 3 plus 7, and then that will finally come out to be 34x. 7 plus 3 is 34x to the 10th power. Exercise 18. Let A and B be numbers. Use the distributive law to rewrite the expression in a simpler form. Okay, so they want us to distribute. So multiply A times A. So that'd be A times A plus, and then multiply second A times B. So that simpler form, I have an A to the first, I have an A to the first. They are same bases, so that'll give me the same base. Add the exponents. I'm just showing all of my work to see where all this comes from. And then I'm going to add A to the 1 times A to the B, B to the 1, I mean, and they are not like terms, so I cannot do any more with this portion. So that is finally going to be, let me stop here because I'm working horizontally and I really don't like that. So let me stop right there, go back. And so I have a to the 1 times a to the 1, which is a to the 1 plus 1, plus a times b, which is simply ab. And then finally simplify. A to the 1 plus 1 is a squared. And then a times b cannot be combined or simplified. And since there's a plus sign in between, I can't add them because they aren't like terms. So this is the simplified form of a times a plus b. Okay, exercise 19. Let a and b be numbers. Use the distributive law to rewrite the expression in a simpler form. Okay, it's the same as before. So I'm going to get b times a. Okay, so I like writing them in alphabetical order. A times b plus b times b. That's b to the 1 times b to the 1. That is going to come out to be just simply ab plus b1 plus 1, which is ab plus b squared. Okay, ab plus b squared. Okay, exercise 20. Let a and b be numbers. Use the distributive law to rewrite the expression in a simpler form. Okay, and we call this FOIL. We're going to do first, outer, inner, last. It's a distributive property, basically. So FOIL means first. In other words, we're going to take a times a. And that is going to, I'm just going to write everything out. A times a plus. And then we're going to do a times b. Here's my outer. Oh, outer. A times b is a times b. I'm just going to write it a times b for now. Plus b times a. And then finally, and that was my inner, my inside to I, FOIL. And then L means last. B times b. The last one of this parentheses times the last one in this parentheses. So that's going to be plus b times b. Okay, now I'm going to simplify this. Remember, this is to the first power. These are all to the first power, all to the first power. If there is no number there, it is to the first power. I have a base, two bases that are the same that I'm multiplying. I'm going to get the same base. I'm going to add its exponents. Plus a times b, they're not like terms, so they're going to just stay ab. Plus another b times a. Let me just put them in alphabetical order because 3 times 2 is the same as 2 times 3. Multiplication's commutative, order does not matter. And then finally b to the 1 times b to the 1 is b to the 1 plus 1. So this is going to give me a squared. ab plus ab is going to be 2 of them. So we can just simply say 2ab plus b to the 1 plus 1, which is b2, b squared. Okay, so when I FOILed that, that's called a binomial, I got a trinomial, 3 terms, a squared plus 2ab plus b squared. Okay. And this is an important formula in algebra, important property, distributing, multiplying 2 binomials. Okay. So in general, if x is not 0 and m and n are positive integers, then now we're dividing. X to the m divided by x to the n equals x to the m minus n. So going back here, all the way up to that last problem, when we are multiplying, we add exponents. Okay? When we are dividing, we subtract exponents. See the difference? Okay, so first we also have to make sure the bases are equal. So I have a 7 base, I have a 7 base, my answer is going to have a base of 7. I have a 9 in the numerator, a 6 in the denominator, and it says to take the numerator and subtract the denominator. So I have 9 minus, let me change colors. I have 9 minus 6. That is going to equal 7 to the 3. Okay. Next question, our exercise. 8/5, 8/5. 8/5 is my base. Leave it in parentheses. We'll explain that more in class. If we don't have parentheses, if we put a 9 out front, it's only going for the numerator 8, so we need parentheses. I think I mentioned that in lesson 1. Now we have 8/5 to the 9 and 8/5 squared. We're dividing, which means to subtract the exponents, so it's going to be 9 minus 2. So my answer simplified is going to be in parentheses 8/5 to the power of 7. Okay. 22. -5, -5. Bases are the same. They're in parentheses. They must stay in parentheses. My exponents are 16 and 7. We subtract when dividing, so it's 16 minus 7, which is going to simplify out to be -5 to the power of 9. Okay. 24. 13, 13, 13. Base 5 minus base 4 equals 13. The 5 minus 4, which is 13 to the first power, or simply 13. Okay. Exercise 25. Lots of exercises in this. Okay. Let A, B be non-zero numbers. What is the following number? A divided by B to the 9th divided by A divided by B to the 2nd will give me A divided by B to the 9 minus 2. A minus B to the power of 9 minus 2. That is going to equal A divided by B to the 7th power. Exercise 26. Let x be a non-zero number. What is the following number? Okay, my base is x, my base is x, my base of my simplified form will be x. My exponent's 5, my exponent's 4, it's 5 minus 4. Numerator minus denominator powers equals x to the 5 minus 4, which is 1. And again, that does simplify out to just be simply x. So what number could x be? Any number. Infinity. Infinitely many solutions. Okay. Can the following expressions be written in simpler form? If yes, write an equivalent expression for each problem. If not, explain why. Okay. I have a 2 base, I have a 2 base, I have a 2 base, I have a 4 base. So I just remember what happened here. 4 equals 2 squared, or 2 times 2. Okay, so 2 squared, that would just be the 4 portion. To the power of 2 would be 2 times 2 times 2 times 2, which is 4 times, or 2 to the 4th. Okay, so 4 squared is the same as 2 to the 4th. Okay, so we went from here to here. Now we have the same bases, so my answer is going to have a base of 2 and 7 minus 4. Okay, and that is going to keep me with a base of 2. And 7 minus 4 is 3. Okay. Base 3 will leave me with a base 3. 5 minus 2 times 2 times base 2 leaves me with a base 2. 8 minus 3, and that is going to equal 3. 5 minus 2 is 3 times 2, and 8 minus 3 is 5. Different bases, I cannot simplify anything. Okay. Okay, and this one here, keep in mind, 27 is 3 times 9. 9 is 3 times 3. So therefore, from our factor tree, 27 equals 3 times 3 times 3, which is 3 cubed. So that's how we went from 27 to 3 cubed. Okay, now we have the same base. So if our bases are the same, 3 and 3, our solutions, our simplified forms base will still be 3. Then we take our exponent, 23, minus 3. And that will yield the simplified version. That tells us our base stays 3, and our exponent is 23 minus 3, which is 20. Okay. And exercise 30, negative 2 divided by negative 2 will give me a base of negative 2. Keep it in the parentheses. 7 minus 5 times 95 to the power of 5 minus 4. That will simplify to negative 2 to the power of 2 times 95. 5 minus 4 is 1. I'll just stop there and write 95. And there it is in simplest form. Okay, exercise 31. Let x be a number. Write each expression in simplest form. 5 over x cubed times 3x to the 8th equals what? I'm going to rewrite this. 5 over x cubed. I'm going to put a multiplication symbol here. I'm going to put a 3x to the 8th over 1. So I'm making this over 1 and making anything divided by 1 as itself. So I can do that. Multiplication is commutative, so I can rearrange. 5 times 3x to the 8th is the same as 3x to the 8th times 5. Leave the x cubed where it is and leave the 1 where it is, and we can actually legally do this in math. All I did was moved like terms under each other. Multiplication is commutative. Okay, I switched the tops, left the bottoms where they were. Now I have like terms underneath each side. So I'm going across here because there's 2 problems right underneath. So now I have a 3 divided by, that's 1x cubed. 3 divided by 1 is 3. I have a base of x, and I have 8 minus 3, and that is going to be multiplied by 5, or just simply 5 over 1. Now I'm going to simplify that any further, and that's going to be 3x. 8 minus 3 is 5, and I multiply that by that 5 again. And finally, I can multiply this 3 and 5 and get 15x to the 5th. And that is my final answer. Okay. It takes a little bit of practice, and there will come a time where you can do it a shorter way, and it gets much easier once you practice this more. So again, I'm going to put a 1 over here. Then I'm going to rearrange it. Negative 4x to the 6th over x to the 3rd times 5 over 1. Okay, I just rearranged the tops. Negative 4 divided by 1x cubed. Negative 4 divided by 1 is negative 4. The base stays the same, x divided by x. 6 divided by, we subtract, and then multiply that by 5. 5 over 1 is 5. Okay, so I'm going to do 2 things here. I'm going to simplify this, I'm going to multiply this. So that is going to equal negative 20x cubed. Okay. And number 31C. I'm going to do the same here. I'm going to put that over 1. I'm going to rewrite it as 11x to the 4th over x to the 3rd times 5 over 1. I'm going to put a 1 in front of this x. 11 divided by 1 is 11. X stays the same base. 4 minus 3 times 5 over 1, which is simply 5. I'm going to do 2 steps at once here. I'm going to simplify my base, or my power, and I'm going to multiply my coefficients, or my numbers. And that is going to give me 55 x to the 1st, or just simply 55x. Exercise 32. And use an online calculator to multiply. That's 1,000, 100,000, 10,000, million, and that's billion. And this is trillion. So 2 billion times 2 trillion. The answer showed up on the calculator as 4e to the 20 plus 21 as shown below. Is the answer on the calculator correct? How do you know? Okay, so first thing I do is look at the numbers that are not zeros. 2 times 2 is simply 4. So I'm okay with that. E is scientific notation, which tells you how many decimals to move to the right. And this has 21. So this is 4 point blah, 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 however many zeros there are. And there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 3, 6, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 for the first one. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for that second one. Get these dots out of the way they were intended. And that is going to give me a number that would be 4. And then how many zeros we have. And there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. And 3, 4, 5, 6, 7, 8, 9 here. And 9 plus 12 is definitely 21. So that's telling us to move this decimal 21 places to the right and give us that really big number. So is the answer correct? Yes. How do you know? There's the explanation. The number of decimal places. That decimal had to be moved to make it really big. Okay, and that is the end of lesson 2. Go to your problem set.